All right, welcome everyone. Cool. Well, I am Alex Louden, and my talk is Idiosyncrasies of Asynchronicity, or talking about async. I work at a little company called Bonobo. We have these three apps that are beautifully drawn here. There is Actions, Time Page, and Flow, and we're a product company. So we partner with Moleskine, the notebook company, and we release the products together, and we split the revenue, and it works really well. We maintain like ownership and kind of autonomy in those products, but we also get kind of the marketing and the backing of a larger company, so it's kind of a cool thing. Nicer than working in an agency, in my opinion, no offense. We are hiring as well, so a full stack mid to senior person. If anyone is interested, come chat to me afterwards. And I'm just going to show you a little video of Flow, a drawing app. So this is my favorite feature. This is called pencil case mode, and it requires you to have about $3,000 of Apple products. But if you do that, then you'd be very happy to pay for a membership and get advantage to this. So it's really cool. It moves all the tools over to your iPhone, and you have this little handy pencil case. You can control colors and the pen that you choose. But this is the kind of work that we do. So we like very kind of highly polished products that quite simple, but yeah, good fun. I really enjoy it. So yeah, I'm not here to shill our apps. I'm here to talk about async. So I'm going to start my talk with a poem, like I do with all my talks. Roses are red, and so are you. Violets are blue. Async is great. Does anyone not understand that? It's all right. Well, it might make sense later. Cool. So what is async? What are some asynchronous things? In general, I mean, I thought of three kind of main categories. There's like timer-based things where, set timeout is something that will wait for a second and then do something else. There's set interval, there's request animation frame, there's some other stuff like that probably. There's networky things. So, you're sending an HTTP request to another server, you're waiting for it to respond, you're getting a response back. HTTP, AJAX, there's fetch, there's WebSockets, and all the other kind of ways that you would communicate with another thing in JavaScript. Did you know that AJAX stands for asynchronous JavaScript and XML? But everyone uses XML all the time. It's great. And file system stuff in Node is particularly so. Writing to files, reading from files, processing images, anything kind of based on files. If you're running JavaScript on the server, you'll be dealing with async a lot. Yeah, but to understand async, I'm going to jump back in time and look at the history of how we got here. All right, so we're going back in time to 1999. Do you remember 99? We had, I've included a song in like each section, so you get a little bit of a like nostalgic hit. Should be fun. So the euro came out in 99. People switched from using pounds, or I don't know, they still use pounds, don't they? But the Matrix came out, Napster was a thing, and Internet Explorer 5 came out with XML HTTP request, which was, I think, the highlight of the year. So this was how you sent GET requests back in 99 or in 2000 during the .com boost. Yeah? Yeah? Nice. Cool. Or some people are still using it. All right, but I'm not gonna dive into this too much. I'm just gonna talk a bit about the history. But you can see like there's a function that runs when stuff happens when you get a response from the server. We're gonna forward 7 years. It's nice. It's like an audiovisual experience. Google bought YouTube, Twitter was launched, and jQuery 1.0 was released with AJAX. Who's familiar with this? You know it well? used it many times in anger. So jQuery, which is the $, has a bunch of stuff. Ajax is one of the functions. You can type in the URL that you want to send something to, the data, and then there are these things here that will run when stuff happens. This introduces the concept of callback functions. This is also a very 2006 font as well. I hope you appreciate that. So callbacks were kind of the first way to structure async things in JavaScript. And at the time, it was kind of the only way that you did things. Like we didn't have all these newfangled things that I'll talk about later. So this would do a GET request to profile, and then on success, once we got our profile back from the server, it would run this function. So, all right, I'm going to step through just step by step. So this code runs. It talks to our server. We get a response back, and then we get our alert modal. And you can see that we've done a very JavaScript thing, which is excellent. So how do we handle errors? There is also an error thing here. You can pass in the function that handles, if the server responds with an error, or if your internet's not connected, or if the request times out, or something like that. We can put all these functions inline as well. So imagine, for this talk, I'm going to kind of walk through basically the example of you fetch a profile page, it has some data, and then you have a bunch of posts on that profile, and you want to fetch each of those posts one by one, or maybe in parallel. So here, we're fetching the profile, we get some data back there. We say welcome data.name now, rather than just the data object. And then we run this function fetch posts. And this fetch posts function might look something like this. So back when we were using Ajax, you would get an array of posts passed in. You would run Ajax a bunch of times for each of those posts. It would send that all off kind of at the same time. And then we would increment a counter for how many posts we've got back. And then when we got back all the posts that we wanted, I'm not sure if there's an off by one error there or not, I don't know. Then we would log done. So it would look something like this. We would send a GET request, then we would send a bunch of other GET requests in parallel, and then when the last one of those was returned, it would send done. But let's say, look at this, so fancy. What happens if the server returns 50 posts or 500? So do we want to make 500 requests in parallel? Is the browser going to be happy? Is the server going to be happy? What happens if one of those fails? Oh. Should we retry? Should we handle 500s differently to how we handle 404s, 401s? Probably should. There's kind of some complex logic involved in handling all that stuff. Maybe instead of sending them all in parallel, we should send them in series. Maybe this would be a little bit slow if we want to, load twitter.com and all the posts loaded one by one. I don't know, might be better than the current experience, where it just takes you to the stop. Maybe we should load them, 5 at a time, where we load 5 posts, wait for those 5 to load another 5. It's kind of inefficient though, like we're, say post number 2 takes a whole bunch longer than the others. Maybe we want to load them in limited concurrency instead. So, we only load a maximum of 5 requests at a time. But how do we do that with callbacks? It's kind of complicated, kind of messy. There's some ways to do things like that. There's, this handles requesting stuff, and on success, we put the data into an object, and then we increment a counter, and then if there's an error, we do some other stuff. But it's kind of a mess. It's pretty hard to follow. I wrote it, and it's hard to follow. So yeah, at the time, back when you do this kind of stuff, I mean, maybe you still do this kind of stuff, I don't know. I'm not judging. There are a lot of libraries to handle kind of complex async stuff with callbacks, but as with all things in JavaScript. There's like 1,000 different libraries. They all suck. They're all like 10 megs. And everyone picks different ones. So it's very JavaScript. The other thing about writing callbacks is it gets very nested. You know, if you want to send a request and then do something else and then do something else, you know, fetch stats for each post, you get this like really nice triangle. Some people call it callback hell. I don't know. In general, I find that kind of thing really hard to follow, especially when you start adding in like error states and error handling and retries and like, you know, handling 401s and 500s and 404s and that kind of stuff. You know, obviously you can write this in a different way, but then you'd be like jumping around in code blocks and yeah. In general, yeah, don't really like them. Not a big fan. But (2011). Game of Thrones came out, but I think everyone can agree that jQuery 1.5 was the most exciting announcement of the year. Came with Deferred Objects, which kind of a few years later led to something more exciting. I'm not going to go into them in more depth, but in general, they look like this. When you do an AJAX request, you get this thing. You can then do .success to that to add it later. And it allows for kind of a bit more complicated like handling of this stuff. Is this looking familiar to people who are alive in those years? Cool. All right, 2015. Cool, ES6 was released. I looked up all the like major events, like, you know, what I've talked about previously, but they were all like terrorist attacks and really depressing stuff. But I did find Pizza Rat, which was like a very popular video at the time, apparently. So yeah, New York, pretty cool. In ES6, there were a bunch of cool things, and promises were pretty cool, probably the most relevant to this talk. So you can see here, I'm just using the Chrome DevTools, and I wrote p equals fetch profile, and we get this thing that is now pending. So it's not like the contents of our profile. It's not like a JQXML object or whatever the thing in the previous slide was. It's a promise. So you can see I typed p again later, and it went from pending to fulfilled, which is cool. So a promise is basically, I don't have the thing yet, but I will. It's a way to say like, anyway, moving on. Yeah, that's right, exactly. Or I might fail, who knows? So promises start off as pending, and then they can move into either two states. They're either fulfilled if it succeeds, or they are rejected if something goes wrong. You chain on like using the .then function to handle the fulfilled state, and you can catch errors with hey, catch. So using our same example, we get fetch, and then we can chain on .then and get the response. So here, this is just, we fetch the profile, then this function runs, and here we're just logging the status code. So we don't actually have the response itself yet, because that needs an extra step. In this case, we're using this response.json function, which returns a promise that resolves with the result of parsing the text to JSON. So the wording is a little bit weird. It's not a thing that returns the response. It returns a promise that will then later resolve to give you that response. Yeah, and what we're doing here is kind of cool. We're doing something called promise chaining, which means that instead of our code going in and in like this, it can just go kind of linearly. So as long as then returns another promise, then you can chain on another then. Does that make sense? Kind of. Yes. All right. Yeah, so response.json is async. We're returning that from this then deals with what's returned from the other then. It's a great syntax. Everyone loves it. You can do this, but you shouldn't. So this is the same kind of, the previous slide, we get our response object. We then chain in and we go in but this kind of leads to more chances for mistakes and really weird nested code, really confusing, this isn't actually returning, so this isn't returning a promise, this is just then later doing some stuff, so you're not actually waiting for this. You can't then chain on thens here because this is returning undefined. It's naughty and you shouldn't do it. So what you should do instead is this, nice thens, and you can also add on catch. And in this case, this will run when there is either of these two promises, either the fetch promise or the response.json promise reject. So if there is an error fetching the URL, or if there's an error turning the response from JSON into an object, then this catch line will run, I'm pretty sure. Correct me if I'm wrong. So the other cool thing about promises is that you can turn callback-based APIs like setTimeout into a promise. So in this case, we're constructing a new promise object here. We get two functions, resolve and reject. And then in our callback-based code, we can call resolve, and then sleep will be resolved. It'll return a promise, and then it'll be resolved. And then we can chain on then to our sleep object. And after a second, we will get an alert, in theory, which is pretty cool. Promise.all is also a thing. So this allows us to wait for all the promises that are within this array that we pass to it to be resolved. So it's a way to kind of aggregate multiple promises together and wait for both of them to be done in a way that's nicer than keeping track of with a counter or checking to see if an object is all filled up or whatever. So in the same way as before, I've just opened up Chrome DevTools. I'm looking at our promises, and you can see that it's fulfilled, but with an array of two responses. And here we're just logging that response object. So we do console.log on that data, and we can see that we've got an array that is containing two response objects. So our example from before, we might want to do something like this. We take our profile, we fetch it, we convert the response into JSON, we get all that JSON as an object, and then we iterate through our nice posts response array. We're using map now in ES6, which is pretty cool, and other functions. So this now, fetch will return a promise for each of these posts. So we'll get an array of promises. They will go to promise.all, which will then get returned from this then, and then that will go down into this then. So then this will log all the response from all of those things. Does that make sense? It was a bit of a mess. But cool. So now that we are promise experts, we can move on to 2017. And once again, oh, shame. Usually gives me more time for a water break. So in 2017, they had decided that instead of ES6 and ES7, we're going to call it ECMAScript 2017 for some reason. So numbering scheme is all a mess. But basically, ECMAScript 2017, the new JavaScript spec was released. All the browsers adopted it. Node adopted it. And along with it came async and await. And it's important to note that async and await are just syntactic sugar on top of promises. You still use promises under the hood. Async and await are just a nicer way to deal with those. So async is the first step in using async and await. So you take your function and you mark it as async, and you say that now it is an asynchronous function. So instead of it returning a string, it will now return a promise, which will resolve to return a string. So here, again, in the Chrome DevTools, I've just copied and pasted my code in, and then I've run it, and you can see that it fulfills straight away to give me that string. So there doesn't even have to be any gap between like it running. You can return a resolved promise straight away. And then the next part to async and await is the await keyword. So this is only valid within the context of an async function. And what it lets you do is basically wait for that promise that fetch returns to be resolved or to throw straight away. So it will actually wait on this line before proceeding to the next line for that promise to be resolved. So it means that we now have something like we would in Python or another language that is like blocking on async calls as opposed to just, powering on through. So previously, if we did this, we wrote a function that would sleep for a second and then log number 1, and then down here it would log number 2. This function would log 2, and then it would wait for a second and then log 1, which from reading it, you might not realize. Like it's kind of weird that straight away this just executes through, like you're just setting up a function that will be run in the future, but it doesn't actually get run now. You have to wait for that to happen later. So instead of logging 1 and 2, it logs 2 and then 1. But in our async example, if we await for sleep and then we log 1 and 2, it will do something a little bit differently. It will do a 1-second pause and then 1 and 2. And it happens in sequence with the way that the code is written, which is nice. So it's actually waiting on that line for a second before proceeding to the next line. So I find it a lot easier to follow that kind of logic instead. So to take our previous example, instead of chaining fetch and then we can now await our fetch and then await our response.json. And here we get back that data, we can log it, we can do anything else with it, we can return it. You can look at both the response object at the same time as data because they're both in scope. So you can check like the response.status code or whatever, and then convert it to JSON, but only if you want to. Yeah, the first function I find a little confusing. You're like returning this promise and then it has a bunch of functions added to it, but you're like returning on the first line, not, and you kind of have to make sure that these functions actually return the promise that they're from that then, otherwise bad things will happen. So like, pretty good, but pretty nice. Our judge is happy. So you can even return and await in the same line, which is kind of nice. So, you don't necessarily need to put the await there, which is kind of a confusing thing. So because this is a promise, your function can return that promise, but instead you could, depending on how you wanted error handling and stuff, it's nice to have it in there like that, just trust me. Error handling with await is kind of cool. It's pretty easy. You use try catch. Promises that are rejected get thrown, you catch them, and then in this case you would handle some HTTP error. So our example from before, we can catch any errors related to the actual fetch. So the server doesn't respond, it times out, you don't have internet, that kind of thing, any kind of HTTP related error. And then later here in our JSON decode, we can handle any of the JSON decode errors. So if our API has returning something that is not JSON, maybe it's returning XML or a string or an error message or a 500-page or something, we'll get an error here instead. We can also handle non-OK responses. So response.OK is an object if it's a bool. It's true if the status code is like 200 or 201 or something happy, and it is not OK if it's like a 400 or 500 or something like that. I don't know about 300s. It might be OK. I don't know. You can look that up. So with ES 2017, now we have this nice array destructuring syntax. Are people familiar with that? So you take this like 2-part array and then you can deconstruct it into 2 variables. It's kind of nice. So it lets you use this really elegant syntax to do 2 things at the same time asynchronously. So it's a lot nicer than doing it with the like then callback based or the promise based version, I think. Like back before this syntax was a thing, you would have to do this. Same as before, our nice like promise.all mapping. We do the same thing here, but it's now like a variable posts instead of relying on like promise chaining, which I find a little bit easy to read, and it kind of logically, I think it makes a bit more sense. There's like no potential to mess up the promise chaining in the same way that you could if you had like error handling or conditionals or other stuff happening in there as well. So yeah, John Cleese is happy. I'm going to talk quickly about concurrency patterns. So I mentioned a few before. This is how you would do parallel requests in async await. So you would use promise.all, and then you would just take your array of data and map over this function. This function would return a promise. So you now have your nice array of posts all fetched in parallel. In series, what you can do is use for and of. So you do a for of loop, and you have await inside that for loop, and you can actually load them sequentially. So when the first line runs, it then waits again for that await and then continues. So this is a really nice way to, if you don't want to do like all your async fetching in parallel, you want to do it just one by one. A library I really like for limiting the concurrency, like being only able to do two things at once. Like say you have two threads, like threads here is kind of a loose term. You might be familiar with from other languages like multi-threading. But essentially what you're doing is you're making sure that this function here only runs two at a time, or whatever you set this concurrency to. So say you are sending HTTP requests, you're enqueuing some work on the server. You don't want to overwhelm the server by sending 200 things or like 2,000 things at once. Like maybe you're restoring a database backup and you want to do it slowly so that you don't overwhelm the database or data store or API or something. This is a really nice way to do that. You probably would do this more in Node than in front-end land, but yeah, could be useful. Retry is also a really handy thing. So this is a library called Async Retry. If you can't remember that, then I'm sorry. I can't help you. It has exponential backoff. So it starts off as roughly a second, and then there's like a random factor of 2 as well. So it will try to run our fetch post function, which returns a promise. If that fails, then it will wait and it will try again. If that succeeds, then it's cool, it just returns that. But if it fails again, then it will double that the following time. So it might have slept for like between a second and 2 seconds the first time, then it'll sleep for 2 to 4 seconds the next time, and so on. So we're waiting for longer and longer. So this might be good where, say your API is overwhelmed, you want to slowly back off and make sure that there's not like 50 people with their web browser open or like hammering your site every second, because that's just going to further overwhelm your server. So there's really nice, like this is a pretty elegant like API for doing that kind of thing. And if this all fails, like if you hit this max retries, then the whole thing will actually throw an error as opposed to just returning and resolving. And that's it. Well done.